Humans have been explorers since the earliest days, from our birth in the cradle of Africa, spreading across the 7 continents. That exploration will never end. It's something very deep within us as human beings. It stretches back to the dawn of our species.
Today, a new breed of explorers are capturing the first glimpses of worlds beyond our own.
We are absolutely pushing the limits of everything we know about space exploration right now.
Hang on to your seats because the roller coaster ride is on.
Mysterious new images reveal incredible new discoveries. January 2016, NASA releases a new image of a strange structure on the surface of Pluto. It appears to be an enormous ice volcano on what should be a geologically dead planet.
On the flanks of this big summit depression is the caldera of the volcano. Nothing like this has been seen anywhere in the solar system. It's got us baffled.
Now, scientists believe that just beneath this volcano is an entire ocean of water. The mysterious image that triggered this discovery is one of thousands that scientists are still downloading from a historic flyby of Pluto in July 2015.
Stand by for telemetry.
Even today, much of the data from the flyby, between 35 and 40%, is still up on the spacecraft and no human being has seen it. We don't know what discoveries will be in them.
How did a team of explorers become the first people in history to capture images of Pluto's surface? And what can explain mysterious new photographs like Pluto's volcano? A team of young university students and scientists set its sights on the last unexplored planet in the solar system.
You know, if somebody said, well, were you all obsessed with Pluto, I think we would all have to plead guilty.
At the time, Ralph McNutt is a physics professor at MIT.
I think I did always dream of being an explorer. I've been a space cadet since I was a kid. And at that time, Pluto was just this incredible big question mark. All we knew was it was a spot of light in the sky.
But with the dwarf planet 3 billion miles away and smaller than our own moon, even the best telescope images are too small to reveal any detail.
The best image from the Hubble Space Telescope of Pluto is this fuzzy ball that's about 6 square pixels by 6 square pixels. So here are these upstart kids that were saying, we ought to go to Pluto. We ought to finish out the exploration of the solar system. So at some point, the moniker Pluto Underground was born.
Yeah, the Pluto Underground. I like to call them the Pluto Mafia. These are the folks who, spent almost their entire careers studying Pluto. Pluto was the end game. This was our opportunity to finish the task of the exploration of the solar system.
Young graduate students, united by their fascination with the outer solar system, the Pluto Underground, want NASA to make their dream a reality, and one man would lead them there, Dr. Alan Stern.
We weren't going to answer specific questions. We were going to collect data sets with our eyes wide open to see what was there, literally exploring, literally flying into the unknown.
The Pluto Underground form a plan to fly a spacecraft within 8,000 miles of Pluto's surface, almost 30 times closer than the Moon is to Earth. As it flies overhead, the probe will turn and snap the first photographs of the planet's mysterious terrain. But the plan faces an uphill battle.
NASA could be doing quicker missions closer to home, and trying to mount an inexpensive mission all the way to the edge of the solar system is a fool's folly.
Alan is a very unique person, and I think this was almost superhuman act of absolutely dogged determination over the years that made this happen.
Dr. Stern is hopeful that the images will solve an ancient mystery. Pluto orbits in a mysterious region of space, densely packed with unusual moons, dwarf planets, and other misfit objects.
The final frontier in the solar system is the Kuiper Belt. This region of leftover objects from the formation of the solar system, and Pluto is the largest of those objects. It's a very important region for understanding the birth of the solar system.
This means that Pluto is a 4.5 billion-year-old fossil, holding clues about how our own planet was formed.
The Kuiper Belt was discovered, and Pluto went from being this lone misfit in the outer solar system to the biggest, the baddest, and the brightest member of that entire population. This was a very rich scientific target. After all, it's a long way away, so you better have an awful good reason.
In 2003, the Pluto Underground convinces NASA, and the New Horizons mission is born.
We had a lot of difficulties associated with getting to Pluto, one of which is it's 3 billion miles away.
We're driving to, 33 times as far from the sun as the Earth is.
The longer a spacecraft travels, the greater chance something could go wrong. So the team wants to reach Pluto within 10 years of launch.
The New Horizons spacecraft was going to be the fastest ever to leave the Earth, more than 30,000 miles per hour taking off.
That's more than 50 times faster than a jetliner.
To cross a 3 billion mile ocean of space required us to travel at this crazy speed. When I was a boy, Apollo missions took 3 days to reach the moon. New Horizons is going to reach the moon in 9 hours. How's that for speed?
To achieve that record-breaking speed, New Horizons must be light. The less weight a launch vehicle has to push against Earth's gravity, the faster it can go. The size of a small piano, New Horizons will weigh just 1,000 pounds, and it can carry only enough fuel for minor course corrections. Once it reaches Pluto, it cannot slow down and enter orbit.
There is no second chance. You're flying by, there's no stopping it. The spacecraft is on a path, a beeline past Pluto. Either you were going to get it or you weren't. And it's terrifying, to tell you the truth.
But if it works, New Horizons will capture thousands of images in incredible close-up detail.
3, 2, 1. Ignition and liftoff of New Horizons.
It was a picture-perfect launch. It couldn't have been any better. But still, it was yet another 9.5 years before we finally get to Pluto.
But there's plenty to do while the team waits, including a close pass of another planet.
We needed to pick up some extra energy in order to be able to actually get to Pluto on schedule.
We had this opportunity to fly near Jupiter, steal a little, gravity assist from Jupiter, and increase our speed by 20% and cut 3 years off the travel time to Pluto.
In February 2007, Jupiter's gravity propels New Horizons like a slingshot toward its destination. After nearly 9.5 years of traveling through space, New Horizons is a mere 10 days away from its historic flyby.
I got a frantic call from Alan Stern, the principal investigator, and I could tell that he was breathing hard. He was running down the hallway, and he said, "We've lost communication with the spacecraft."
This had never happened in 9.5 years of flight. How could it be happening today, at the last minute, just on the verge of summiting Mount Everest? Why now? How? What have we done?
"10 days from a historic encounter with Pluto, the New Horizons spacecraft goes silent.
We have no spacecraft, no signal, no knowledge of what's going on. It started to sink in that we may be experiencing something that's abnormal on the spacecraft. And I can't tell you how that feels.
Alice Bowman is the mom, or mission operations manager for New Horizons.
You allow yourself those 10 seconds of feeling, oh my God, what's going on? And then, your training kicks in.
Alice was in charge of the recovery effort, and there was no way she was going to let this fail after 9.5 years.
Alice scrambles the team to assess the damage, and they make a heart-stopping discovery.
It turns out that we had overworked the main computer on the spacecraft and caused it to reset.
6 months of programming are lost. Now, the engineering team has only a few days to redo everything.
We knew we could fix it. The question was, could we fix it in time? for the flyby sequence that was supposed to start on July 7th.
Over the course of 3 sleepless days, the team uploads command codes to New Horizons, nearly 3 billion miles across the solar system.
We were able to get that sequence or set of instructions loaded to the main computer. And we had 4 hours to spare.
If you've got high blood pressure to begin with, this is probably a business you ought to stay out of.
7 days later, the morning of the Pluto flyby has come.
Hang on to your seats because the roller coaster ride is on.
As media from across the world gathers at Johns Hopkins University outside Baltimore, Maryland, all eyes are on Dr. Alan Stern.
We passed inside the orbit of Hydra, the outermost moon of Pluto.
And he's brought an early surprise for the New Horizons team.
The night before closest approach, we made a point of sending home a handful of images and spectra. They were the highest resolution images that had ever been obtained. Pluto went from being just a small image in the distance, sort of like a jeweled Christmas ornament, to all of a sudden this massive world with unparalleled complexity.
But this is not the image of Pluto the team came to see. It's New Horizons' closest approach that will truly reveal Pluto's secrets. In less than an hour, New Horizons will come within 8,000 miles of Pluto.
But the timing had been off, that we had somehow just messed up, and instead of flying by Pluto at the prescribed time, it was, 1,000 seconds earlier or later. We would have had everything pointed in the wrong place.
You don't want to wait 2 decades and see a bunch of stars.
Okay, we have 25 seconds, folks.
At 7:49 a.m., the team counts down to the actual second New Horizons makes its closest approach to Pluto.
9, 8, 7, 6, 5, 4, 3.
Decades of work, they don't come down to 1 day, they come down to 1 minute, to 1 second.
But no one really knows if the probe survived the flyby until it sends a confirmation signal back to mission control.
Radio signals traveling at light speed are expected to arrive at the APO Mission Operations Center, and we'll go live in the Mission Operations Center so you can watch some of that activity.
At 9 p.m., the team gathers to learn New Horizons' fate.
We are searching for frequency. Stand by.
Waiting for the spacecraft to report back, you could probably have cut the tension with a knife. Everything's riding on this. And it's an incredibly high-stakes poker game.
Okay, we're in lock with carrier. Stand by for telemetry.
You really don't know if your spacecraft survived despite all the work that you've done.
Stand by. Okay, copy that. We're in lock with telemetry with the spacecraft. PI, Mom on Pluto 1. We have a healthy spacecraft. We've recorded data of the Pluto system, and we're outbound for Pluto.
When we got that signal, it was like a celebration for the 10, 15 years of work that we'd put into that mission.
This has been beyond my wildest expectations in every regard. I'm ecstatic. It's returning beautiful data, and the Pluto system is just mind-blowing.
Within hours, New Horizons begins to deliver its first images.
Our jaws were just dropping. It was incredible. We had transformed this little pixelated blob into this real world.
What the team sees in the images
Wow.
is completely unexpected.
Even though logically I knew that it was a rocky, icy planet, I didn't expect it to look so similar to features that we have on Earth.
I love this picture. It's one that was made about 15 minutes after closest approach. the very rugged terrains. Many of these mountains are 10,000 feet tall.
The team has discovered mountains of water ice the size of the Rockies on a planet smaller than our own moon.
You felt like you're there, seeing the giant ice mountains and giant chasms, much bigger than the Grand Canyon in the United States. We can actually see glacier flows. It's molecular nitrogen ice. It's almost like water ice is on the Earth, and so it can flow.
The discovery of water ice mountains and nitrogen glaciers leads Alan to one shocking conclusion.
Pluto is geologically alive after 4.5 billion years, which upended many geophysical theories that did predict that small planets would cool off and die early in their history and just be a frozen relic of that time. It tells us that our ideas of how planetary engines work were wrong, and that we had to rethink them.
But one recently downloaded image further fuels Pluto's mystery.
This is one of the most amazing finds we made at Pluto. It's a giant ice volcano that was apparently active late in the history of the solar system. There are almost no craters on the flanks of this structure. The big summit depression is the caldera of the volcano. Nothing like this has been seen anywhere in the solar system, from Mars all the way to Pluto. Sometimes I pinch myself that this is a real place that we actually went and visited. It looks like something out of science fiction. And why Pluto should have these features has got us baffled.
An active volcano would mean a source of heat somewhere on the planet. And now, the New Horizons team believes that heat could be warming an ocean of water beneath the surface of Pluto. It is a stunning discovery.
You have, all of these other exotic things going on. What looks almost like tectonic activity. And, where is that coming from?
Why is Pluto still alive? New images might solve the mystery.
The blue sky image, this is something that was absolutely totally unexpected.
The discovery of active geology on Pluto has defied expectations of a frozen, dead world.
There were mountains of pure ice that were 10,000 feet high. There were active glaciers of nitrogen and methane ice. Nobody was expecting the drama and the beauty that we found.
But Pluto's biggest mystery may lie above the surface.
After we fly by Pluto and look back towards the sun, and we can actually see the atmosphere and see that it's blue. Pluto has blue skies. Who would have thought? It's just amazing.
This blue atmosphere of nitrogen should have dissipated into space billions of years ago. Something is replenishing it. But what? Could volcanic activity spew fresh nitrogen from deep beneath the surface? New images might soon solve the mystery.
We've got over a year's worth of data to still get down. There's a lot of people that are losing a lot of sleep these days trying to do this as fast as possible. But by far the best images are still to come.
The search for answers takes us from the edges of the solar system to the edges of the universe itself. March 4th, 2016, NASA releases an historic image, one that many believed was impossible. This red dot is an entire galaxy whose light took 13.4 billion years to reach us. It is a photograph of our universe in its infancy, a mere 3% of its current age.
All of a sudden now, you have a ringside seat to watch the entire universe evolve and change in front of you. All of that is down to the Hubble Space Telescope.
What could this mysterious red galaxy reveal about the origins of the cosmos? That story begins when the Hubble telescope is still on the drawing board.
Hubble was meant to solve a problem because people were trying to use ground-based telescopes to measure how fast the expansion of the universe was, and that means a factor of uncertainty in the age of the universe.
How and when did our universe begin? Solving that mystery would be an historic success at a time when the space program needs it most. In 1986, the nation is in mourning after the loss of 7 crew members aboard the Space Shuttle Challenger.
This is truly a national loss. The members of the Challenger crew were pioneers. We'll continue our quest in space. The future doesn't belong to the faint-hearted. It belongs to the brave.
They needed something to get back into the game. And Hubble was sort of that big shining star. This was a big space telescope, and we're going to put this thing into orbit, and it's going to look at black holes. It's going to figure out where the universe came from. It's going to revolutionize astronomy.
In charge of this daunting mission is Charlie Pellerin.
The primary role of Hubble was to fix things after Challenger, to show we could still do hard things. I kept reminding myself of John Kennedy when he said, we choose to go to the moon, not because it's easy, because it's hard. We choose to do Hubble because it's hard, and it was damn hard.
Hubble will far surpass all ground-based telescopes for one simple reason: Earth's atmosphere.
If you look up at the night sky, the stars are going to appear like they're twinkling, but the star is not changing. What's happening is that the same kind of irregularities in the atmosphere that you encounter when you get turbulence in an airplane, it's all over the place. Now, the solution to that is to put a telescope above the atmosphere.
But unlike ground telescopes, Hubble would be orbiting the Earth at an astonishing speed of almost 5 miles per second. And that's a problem.
Now, of course, the Hubble is this thing in space moving thousands and thousands of miles an hour in orbit, and which means its natural tendency is that it's going to be tumbling end over end. It's doing everything but holding still.
If you want to take a snapshot that's clear, you know you have to hold your camera very steadily. If you shake your camera, you get a fuzzy picture. Same is true with Hubble.
The team must find a way to stabilize Hubble perfectly. The solution is a gyroscope. Like a top, a gyroscope maintains stability by spinning quickly on one axis. The team will equip Hubble with 6 of the most finely balanced gyroscopes ever constructed, each with a wheel spinning 320 times per second. But even the tiniest imprecision in the gyroscopes will smear Hubble's images.
So if you asked me before the launch, is Hubble going to work? And people did. I would say, of course it's going to work, because there's no other answer. What would you say? Would you say, after you spent almost $2 billion in 15 years, would you say, hell, I don't know? Or would you say, let's hope so? Or what would you say? There's only one answer. Of course it's going to work.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Okay, we have a go and release, and we're going to be a minute late. Okay, Charlie.
The telescope's released? Okay, thank you.
So the telescope's up, Hubble's working, it's deployed into space, and the shuttle comes home. Feeling really pretty good right now.
The flight systems are all working extremely well. Almost everything we agonized and worried about has done a great job for us. I think that today everything is going exactly as we would have hoped.
We had an event about 2 months later where we're going to look at what's called first light.
Charlie is with Chief Engineer Gene Oliver when the first images arrive.
I said, Gene, wait a minute. That's a fuzzy spot, okay? He said, don't worry. I said, what do you mean, don't worry? So, well, if it's out of focus, we drive the stepping motor in this direction until it's in perfect focus, so no big deal.
Charlie becomes convinced all that's needed is a technical adjustment. He leaves for a trip overseas. When he returns, he calls his boss to check in.
So he comes on the phone and says, Charlie, where are you? I said, I'm in the carpet lounge in St. Louis Airport. And he says to me, what do you know about spherical aberration? And I said, well, all I know is that when people, amateurs typically, make a telescope mirror by hand and they do it sloppily, then the telescope's useless. I said, well, I'm glad you know that, because you launched Hubble Space Telescope with a spherically aberrated mirror. I said, did not. He said, did so. This is 2 PhDs, right? And he says, go find the front page of any national newspaper and bring it back and read it to me. So I come back, and above the fold, national disaster. Hubble launched with flawed mirror. And he says, now what do you say? I said, you guys are good. How did you get a fake newspaper into this very lounge that I'm landing in?
The headline is no fake. Charlie has launched Hubble with a fatal flaw, and not the one he had feared.
Yesterday, NASA admitted that its multi-billion-dollar eye in the sky has developed blurry vision.
We had failed in the most visible possible thing we'd done in many, many years. I'd have to say it was like a family member died. It was like that. I mean, it really was.
May 1990. Charlie Pellerin had just launched Hubble into space with a fatal flaw.
Well, we're looking here at a star field and these blurry stars, and there's no doubt that we had a disaster on our hands.
Yesterday, NASA admitted that its multi-billion-dollar eye in the sky has developed blurry vision.
The observatory will not be sending back the spectacular pictures that NASA had promised. The reason is that the mirrors are not focusing light properly.
To achieve focus, A telescope's mirror must be perfectly curved so that its reflected light converges at a single point. After so much worrying about Hubble's ability to stabilize itself, Charlie's team made an amateur mistake.
Hubble uses a mirror. It's 2.5 meters across, 8 feet. And it focuses the light to a very, very specific focus. And if it's off by even a little bit, the light won't come to a focus. The problem with Hubble is that it wasn't the right shape.
I believe that the edge of the mirror, the whole error was like a 50th of a human hair. No human could ever look at that mirror and suspect there's a problem. We had so many safeguards, and I look at this and I just go, my word, boy, we were in so much trouble and didn't know it. What a tragedy. Basically, without some novel technical answer, we're screwed.
NASA is embarrassed, while across the country, Charlie and his team are mocked.
There was also so much in the media. Hubble was the butt of so many jokes. People were saying, well, how did we spend almost $2 billion and come up with this?
I tried to avoid the news as much as I could, but it was impossible. It was even in New York Times, Washington Post, and crying breaking out. Astronomers are crying everywhere. One of my most senior people is drunk at his desk. When I realized what had happened, I didn't believe my personal reputation was in danger. I believed it was ruined. I mean, it was gone. I mean, for this level of failure, arguably the biggest screw up in the history of science, and I was the leader of the team. So yeah, it was bad.
But Charlie is determined to find a solution.
I'm not waiting a minute longer than I have to get this telescope fixed. I didn't know how to do it. I had no idea if it even was possible yet.
After months of searching, his team thinks they might have an answer.
If the mirror was simply poorly ground to a very sloppy way, it'd be hopeless. But the mirror was perfect, just ground to the wrong prescription.
When we humans have vision problems, we correct that problem by wearing eyeglasses, which then are correcting the direction of the light and make sure that it is focusing properly. That is basically what the Hubble needed.
These glasses would come in the form of a machine called CoStar. CoStar contains 5 pairs of small mirrors on motorized arms. These mirrors correct the light beam entering the telescope.
And finally, you sort of go, my word, we can fix this thing.
But with Hubble already in space, this repair won't come easy. Catherine Thornton and her fellow astronauts must risk their own safety to save Hubble from disaster.
A lot of things can go wrong when you're on a spacewalk, but most people, when they leave the airlock, are not so much afraid that something's going to happen to them. They're afraid they're going to mess up. That's the sort of your biggest concern is that our mission was so critical, and it was critical that they be done right.
Hubble's science instruments are contained in 4 bays. Catherine must replace one instrument called a high-speed photometer with CoStar. Once installed, the corrective mirrors can deploy.
I mean, remember, this is a huge instrument the size of a bus. Nothing like that has ever been done before, and it represents a huge number of technological challenges.
But Thornton is far from certain that everything will go according to plan.
And I would have bet money that when we were putting these instruments in Hubble, we would have run into some problem that we weren't expecting.
Okay, I'm going to slip over. You got another slip to keep coming up.
CoStar is a great big silver box, the size of a phone booth, and I would have bet that things wouldn't fit. And we're going to slide this thing in, and it's going to get halfway in, and it's going to go thunk and hit something. And as bad as it was, we could always make it worse. We could have killed it. We could have killed it. This is opening the door for CoStar. I'm on the end of the mechanical arm, and I can recognize that from this picture because I can see the broken red stripes around my thighs there. I haven't seen some of this in a long time. This is nice. I like this. We had a lot of eyes watching us. We had everybody on the ground watching. We had everybody in the crew module watching us. You know, don't hurt it. Don't hurt it. Don't hurt it. But it's all up to you. Don't screw this up. CoStar is a pretty big instrument. It weighs several hundred pounds, maybe 700 pounds on Earth, and I can move it with just my fingertips.
The top pitches toward me a little bit, Casey.
As CoStar slides into place, Thornton can only hope that everything will fit.
And it just slid right in. I could feel it hit a stop, but that was a bit of a relief. The nightmare I'd had didn't happen. But they couldn't calibrate it until after we were long gone. And so we had no idea that our mission was successful even after we landed.
All anyone can do is wait for the pictures. 11 days later, the calibrations are complete.
You know, this was what was happening in December of 1993. Everybody gathering around the monitors and looking at the first images taken by Hubble Space Telescope. And they were gorgeous.
I'm sitting here with tears running down my face looking at this stuff. And everybody's spellbound. I had no clue that the images would be as powerful as they are. I never imagined something like this. This is astounding. This has got to be astounding to anybody.
But these are more than beautiful images. Each pixel helps unlock another scientific mystery.
Because people were trying to use ground-based telescopes to measure the expansion of the universe, and that means uncertainty in the age of the universe. But by looking deeper and deeper, it's looking farther and farther back in time, and is measuring the expansion of the universe, so we can tell precisely when the universe formed, 13.7 billion years ago. Hubble has solved, one of the biggest mysteries in astronomy and in science.
With each image, the discoveries keep coming.
They pointed Hubble at a place in the sky where there was nothing, and there are like 1,500 galaxies in that photo. 1,500 galaxies. Our Milky Way is just one tiny little galaxy.
We now know that there are more stars in the universe than grains of sand on all the beaches in the world. But Hubble is also a time machine.
You see, there's this wonderful look-back effect, where the farther out in space you look, it took light a long time to get to you.
And now you look at these images, and you effectively look back almost to the beginning of time, the beginning of the universe with Hubble.
This new image from March 2016 is the furthest look back in time yet. The light from this young galaxy dates to just 400 million years after the Big Bang. It is surprisingly bright, which means that galaxies were growing much faster and much earlier than we ever knew. 25 years after launch, Hubble continues to amaze.
The idea that someone could be interviewing me and putting these images up in front of me and having me comment on them and telling me that we're in our 25th year of successful science operations, that's a mind blower. In NASA, I think Hubble's only second to the moon landing. I mean, it's that big.
Coming up, a team of scientists searches for the origins of life on an asteroid that could also bring us death.
It caused a tremendous amount of damage in the local area where it hit.
As we look farther into the universe than ever before, we may be looking deeper inside ourselves.
One of the most surprising facts about our relationship with the larger solar system we live in is that the organics in our body were most likely brought here to Earth on comets and asteroids.
Rich in molecules called nucleobases, the same molecules that make up our DNA, asteroids could be the key to unlocking the mystery of life on Earth.
And maybe the very origin of your body, of the chemistry that you're using to watch TV right now, came from the asteroids.
One asteroid is especially intriguing. Its name? Bennu.
In the case of Bennu, it's about half a kilometer across rock.
Bennu itself is an exciting object. It's a carbonaceous asteroid. Carbonaceous means that it contains the element carbon, which, as we all know, are associated with life.
Bashar Riz is a scientist at the University of Arizona. But it's not just the possibilities of life that makes Bennu interesting to Bashar. It's also the possibility of death.
Bennu is in a class of asteroids that share the same region of space as the Earth as they move around the sun. And every 6 years, it's in the same general region as the Earth. That increases the opportunity that it would actually hit the Earth and cause damage.
To understand whether Bennu truly poses a risk to Earth, we need to see it. In the mountains outside Tucson, Arizona, Eric Christensen searches the skies above Earth for asteroids and comets.
This object that's circled in red here in the middle, it looks like a faint star, but it just happens to be the asteroid Bennu.
The Catalina Sky Survey is our first line of defense against asteroid impacts.
Asteroid impacts are really a fact of life. They always happen. They have always happened. They will always continue to happen. We will point our telescope at a particular area of the sky, and we will build up over time, essentially a very low-resolution movie. We can compare the images and identify stars that are stationary, and then anything that is not stationary is a potential moving object.
When astronomers discovered Bennu, they quickly realized that of all the near-Earth objects in their sights, this asteroid has one of the highest chances of impacting Earth.
Bennu had come near the Earth, near enough that we could get radar reflection off of it, and therefore we know something about its shape.
To fully understand where Bennu is going, Peter and Bashar need more than just fuzzy radar images. So in September 2016, they will launch a spacecraft called OSIRIS-REx. After 2 years of traveling through space, it will intercept the asteroid. Once there, its mission is twofold. OSIRIS-REx will collect a sample of the asteroid to return to Earth, and it will photograph the entire surface in extreme resolution, taking pictures down to the size of a pebble.
Our cameras will go and try to characterize the asteroid's environment. We're going to image this object to a higher degree of resolution over a larger piece of its terrain than has ever been done before. Mapping Bennu with these cameras is essential because we'll understand the gravity of this object to a much more precise degree. Predicting where this object will be 100 years into the future is very important because this is one of the potentially most hazardous objects in the solar system for the Earth.
To precisely determine Bennu's future orbit, scientists need to know the asteroid's exact size and shape. That's because of a phenomenon known as the Yarkovsky effect.
Any object in the solar system experiences the Yarkovsky effect. Now, what is it? Well, it's a thermal asymmetry that happens because of the rotation of an object.
As the sun's energy strikes Bennu, it gradually changes the asteroid's orbit.
Things have had a chance to heat up. Now, when something is hot, it tends to emit photons, thermal ones. Photons carry momentum. So what this is doing is acting like a little bit of a thrust in this direction. If I thrust that way, I'm kind of increasing the energy of the orbit and moving it out from the sun a little bit.
The high-resolution images from OSIRIS-REx will tell the team exactly how the Yarkovsky effect is influencing Bennu's path.
If an object the size of Bennu struck the Earth, it would be a regional catastrophe, perhaps taking out as much as a state or several states.
They could cause a lot of damage and the loss of a lot of life.
Space is all about exploration, and it's something that we humans seem to kind of be wired with. History has shown that you've got two choices. You can either keep marching ahead, or you can fall behind and end up in the dustbin of history. Standing still is not an option.
Revealing the deepest secrets from space can inspire wonder, but they can also incite fear. This grainy image shows an asteroid called Bennu, and it may be on a collision course with Earth.
Odds of Bennu hitting the Earth are less than 1 in 2,000. That's still considered high for this class of object. Typical odds would hopefully be lower than 1 in a million.
Bennu is smaller than the asteroid that killed the dinosaurs, but it could cause a tremendous amount of damage in the local area where it hits. For instance, it could really damage something the size of a large city, or if it hit just offshore, it could create a tidal wave.
In September 2016, Bashar and Peter will send a probe to photograph Bennu in detail and reveal its secrets. But a mission like this is fraught with potential pitfalls. In August 2014, a spacecraft called Rosetta arrived at another small body, a comet caught in Jupiter's gravity. 3 months later, the Rosetta team attempted to land a probe called Philae on the comet's surface, and it ended in disaster.
Philae was equipped with a couple of harpoons so that when it made its landing, they would shoot out and ideally try to moor it there. Except that apparently the harpoons did not fire when Philae landed.
So because of that, Philae hit the surface and bounced, and it bounced several times because of the comet's rotation and the lander's own velocity. And it wound up coming down in an area of the comet that we didn't have good maps for, and so basically the lander was lost.
The team is determined to see their mission succeed. That's because there is more to learn from Bennu than whether or not it will collide with Earth. It could unlock the origins of life on our planet.
The Earth formed when objects slammed together. But later on, as it cooled and water became a large part of the surface composition, then it was possible for future impacts with smaller objects to actually bring in organic materials that could survive on the surface. That's how many people think organics came to the Earth, is through those impacts from asteroids. When we get a sample of Bennu back into our laboratories, we're going to be looking at material that formed in the initial phases of the formation of the solar system.
If we could someday prove that the building blocks of life on Earth actually came from space and not from our own planet, it would turn everything we understood about the origin of life on its head.
OSIRIS-REx will not attempt a landing like Philae. Instead, it will get a sample of the asteroid with a revolutionary new system called TAG-SAM.
TAG stands for touch and go, and SAM is sample acquisition maneuver. So TAG-SAM is the actual act of reaching out, touching the surface of the asteroid and gathering the sample and pulling away.
Once samples from Bennu arrive back on Earth, we can test them for the kinds of organic materials that could have seeded Earth 4 billion years ago. But to successfully retrieve the sample, the cameras must function perfectly.
The cameras are one of the critical experiments on this mission because as we get closer, it can refocus and actually becomes more like a microscope. And it can detect grains that are just a few millimeters across. So when we get to our sample site, we want to get the highest resolution possible.
With only months to go until liftoff, the clock is ticking to get OSIRIS-REx right.
We'll be launching in September of 2016. So we have a schedule pressure here that I think does take its toll on the team. There are a number of things that we're trying out for the first time, and that keeps people up at night at NASA.
Should the mission fail, NASA will need another way to reach Bennu. Scientist Ben Hockman created a backup plan, and to test it, he's hitting the beach.
I think most people assume asteroids are just big rocks in space, but in fact they have very interesting surface geology. We found through recent missions that there can be a wide variety of different surface features.
With its mix of sand and rocks, this beach mimics terrain that NASA has observed on comets and asteroids. It is the perfect place to test Ben's rover, nicknamed Hedgehog.
Hedgehog is a whole new class of rovers, very different from the previous rovers that we've sent to the Moon and Mars. We've seen that the topology of asteroids can be very uneven, so there's potential that a rover could fall into a pit or a crater and be unable to escape. All right, hopefully this works.
It may not look like much, but on an asteroid, where gravity is a tiny fraction of the Earth's, this same hop would propel Hedgehog far across the surface.
It uses 3 internal flywheels to build up momentum internally, and by doing that, it can hop and tumble across the surface.
These spinning flywheels build up momentum, and when Ben applies the brakes, he transfers that momentum into motion.
Think about it like you're driving your bike and you come to an obstacle and you hit your front brakes. You have a lot of momentum about your front wheel, so you have a tendency to want to flip over your front wheel. The same is true for Hedgehog, but we do that to our advantage to hop in a controlled way.
But to see how Hedgehog will work in a near zero-G environment, Ben must head to the lab at Stanford University.
So this contraption is called our microgravity testbed. The microgravity testbed allows us to emulate what the rover might do in actual microgravity conditions.
The bed shows Ben how Hedgehog will behave on an asteroid like Bennu.
At those scales, gravity is about 1,000 or 10,000 times lower than that of Earth. So on an asteroid, a human would weigh as much as a paperclip. One of the key advantages of Hedgehog is that there's no right way up. In other words, it can land on any side and be just as capable of moving as if it were to land on its feet, so to say.
And Hedgehog holds one other advantage.
Because Hedgehog is so compact and cheap, you can store potentially many of them in a spacecraft that you send to a small body. So you can imagine an army of Hedgehogs hopping around the surface, exploring the physical properties of an asteroid.
For now, Hedgehog is only a prototype, so it will be up to OSIRIS-REx to unlock the secrets of Bennu. The answers won't come until late 2018, when OSIRIS-REx and its cameras finally reach the asteroid.
I think that the images of Bennu are going to be revelatory. Waiting for those images to come back in 2018 and 2019 will be, the only thing I could compare it to would be waiting for the births of my 2 children. Because it's something very important to you, and you're not quite sure of the outcome.
Until then, scientists can only wonder if Bennu will change our understanding of life on Earth.
How did all that get going? Did it start here, or was it brought here from outside? We don't really know the answer to that. We're going to go find out.
If the building blocks of life did come on an asteroid, perhaps Earth wasn't the only planet where they landed. Today, a team of scientists is driving a rover millions of miles away to see if life could have thrived on another world.
You get a flat tire in your car, no big deal, you call AAA. You get a flat tire in the rover, that's the end of the mission.
For years, a satellite called the Mars Reconnaissance Orbiter has been photographing dark streaks on the slopes of a crater. Mysterious lines that appear to change with the seasons. On September 28, 2015, NASA scientists announced their groundbreaking conclusion.
What we're going to announce today is that Mars is not the dry, arid planet that we thought of in the past. Today we're going to announce that under certain circumstances, liquid water has been found on Mars.
Scientists have never found liquid water on a surface anywhere beyond Earth. The discovery is historic.
Life as we know it on Earth needs liquid water to survive, so that's kind of the key first thing that we need. But we also need organic materials, and so those are some basic elements like carbon and hydrogen and oxygen.
In 2012, a rover called Curiosity landed in an ancient Martian lakebed known as Gale Crater. A roving chemistry lab, Curiosity drilled into the soil in search of organic molecules.
One of the last pieces in the puzzle with Mars is that we've never been able to detect the presence of organic molecules. And Curiosity put that puzzle piece in. We know that there are organics in the soil.
We also discovered, and this is really important, we found an environment that wasn't very acidic, and that was really our first discovery of a habitable environment on Mars, where we think life could have existed.
We have found evidence of water and organics. But were they both plentiful on Mars for billions of years? Perhaps even long enough for life to take root. Mount Sharp, the 3-mile high peak at the heart of Gale Crater, may hold the answer. It is a time machine. The higher up the slope you go, the further back you travel in Mars's geological history.
We really were looking to Mount Sharp to tell us the record of environmental change through Mars's history. We think that there's a possibility that as you go up through the layers of Mount Sharp, we may be exploring different habitable environments. And so what we're interested in finding out is how does the habitability as a whole change through time?
Today, Curiosity is entering a new phase of exploration by climbing Mount Sharp. Along the way, it will analyze the soil, piecing together 3 billion years of Martian history. But for rover driver Matthew Heverly, the path ahead is fraught with danger.
We're always pushing the limits of this vehicle. I mean, the rover's amazing. It can handle so much. But as we go to Mount Sharp, we've got some pretty gnarly terrain to head over. There we go.
To find out just what kind of terrain Curiosity can handle, Matthew and Katie take a rover out for a spin.
So we built 3 rovers. We sent one off to Mars. We built an exact copy that we keep here on Earth for testing software and cameras. And then we built another one, Scarecrow, because we have to adjust for gravity.
Mars's gravity is 3/8 that of Earth's, so Curiosity's 2,000 pounds become about 750 on Mars.
Scarecrow rover is stripped down, but it weighs on Earth what Curiosity weighs on Mars. So it's got the right ground pressure. It's got the right, as we're going up a hill, it's carrying the right amount of weight up that hill. So we can test in the Mars yard, how steep a slope can we climb up?
Satellite photos reveal that the most direct path up Mount Sharp would take Curiosity through sand dunes. So Matthew and Katie decide to see just how much sand the rover can take.
Sand is scary for us because we think we understand what's going on, but we get constantly surprised. What angle do you have there?
We're at like 16 and a half.
We would not do this much slip in operations unless we were very sure we could get out.
Yeah.
And then it just gets harder to extract yourself.
What we're learning is that the sand dunes are really just too great of a challenge for the rover to handle. The rover actually does a better job with the steep rocky slopes.
The team chooses a path around the dunes, and Curiosity continues on its journey up the slope of Mount Sharp. Will Mars prove to be a planet where life once thrived? Only time will tell. Coming up, these mysterious images take the search for life to a totally unexpected place, a tiny moon called Enceladus.
This is the single most important and interesting place for astrobiology in our solar system.
October 28, 2015. The Cassini probe captures one of its final images of a mysterious moon orbiting Saturn. Its name, Enceladus. Its diameter is just 310 miles, less than 15% of our own moon. But these photos reveal what appear to be volcanic geysers spewing from its surface.
Scientists are trained not to jump to conclusions. So we weren't going to say, definitely we found something. We thought, Toto, we're not in Kansas anymore. This is something really, really outstanding and something very significant.
Why do these plumes exist? What is inside them?
To me, it eclipses everything else we know about the other worlds in the solar system. This is the single most important and interesting place for our solar system beyond the Earth.
Could this tiny ball of ice actually contain the ingredients necessary for life? In 1977, NASA launches 2 spacecraft on a 12-year journey to the outer edge of the solar system. The Voyager probes send back the first detailed images and data of the gas giants beyond the asteroid belt. But one planet captures the heart of Carolyn Porco.
I was a graduate student when Voyager flew by Saturn. I did my thesis on Saturn's rings, and it's, like your first love, or it's the jolt that we scientists get is, finding something new that nobody else knows about. And all that happened for me at Saturn.
But one moon seems to hold more mysteries than the others. Covered in a thick orange atmosphere, its name is Titan.
It was Titan, completely enshrouded in haze, and we didn't know when we got there with Voyager whether or not we'd be able to see down to the surface with our cameras, and it turned out we couldn't.
Unable to see past the atmosphere, Voyager cannot solve the mystery of what lies beneath.
Titan was an object of immense interest. This was the place that we need to go back to. So when NASA put out this announcement of opportunities saying, come apply to be involved in our next adventures at Saturn, I applied, and I'm so grateful that I had the chutzpah to think, I'm not just going to be a member of the imaging team, I'm going to lead it.
In 1990, Carolyn's dream comes true. NASA places her in charge of the imaging team for Cassini, and this mission will be different.
Voyager, mind you, was a reconnaissance mission. It was just a flyby. And the whole purpose is just to see what's there in the brief period of time that you're allowed.
But Cassini will enter Saturn's system and stay there for years, imaging the planet and its moons with high-powered cameras and scientific instruments.
3, 2, 1, and liftoff of the Cassini spacecraft on a 30-mile trek to Saturn.
In July 2004, Cassini arrives at Saturn. And right away, it delivers on its promise, taking the most detailed images ever of the ringed planet and its moons.
I had been thinking about Voyager imagery, and then I walk into my lab and I see this picture, and it's incredibly detailed. And that's when I thought, oh my God, this is going to be just spectacular. This is going to be a wondrous thing, what we're going to be doing at Saturn.
The Cassini mission brought us a wealth of scientific discoveries about Saturn. For example, it helped discover 4 new moons. Cassini revealed entirely new detail about Saturn's amazing rings and the way that they are moving around the planet.
But for astrobiologist Chris McKay, the real star of the show is Titan.
The reason Titan was so interesting for astrobiology was that it is so rich in organics. There's an organic haze in the atmosphere. We thought that there would be organic liquids on the surface.
Organics are the carbon-based molecules needed for life. Could organic liquids indicate some form of life on the surface of Titan? Carolyn and the team have equipped Cassini to do what Voyager could not: see beneath the haze. And it will happen by sending a probe called Huygens right down to the surface.
So Huygens was designed to drop from the Cassini probe and descend through the atmosphere and make a soft landing on Titan, sending back information the whole way about what Titan was actually like, and finally giving us a chance to peer through these murky clouds on the surface.
On January 14th, 2005, Huygens makes its descent.
When the Huygens probe descended through Titan's atmosphere on a parachute, it was taking images of the surface. We didn't know what to expect, but it showed what looked like shorelines. When we got pictures of the surface, it was very clear that there had been liquid of some kind on the surface for a long time.
But Titan's surface is nearly minus 200 degrees Celsius, so that liquid cannot be water.
So Titan has clouds, it has rain, it has rivers, it has seas, but it's methane and ethane. And the real question for astrobiology is there some sort of chemistry that could make life, that could live in this kind of liquid?
For life to exist on Titan, it would have to be so alien that it survived on methane instead of water. Although Chris McKay is hopeful, it's a long shot. But Titan is not the only moon orbiting Saturn.
Enceladus was a moon that we knew from Voyager was unique. It was the whitest object in the solar system. It was the brightest object in the solar system. It was associated with a very big ring of very, very fine smoke-sized particles that had been discovered around Saturn in the 1960s. Enceladus was the place that we were just puzzled about. And other than Titan, Enceladus was the moon that on Cassini we had planned to have the greatest number of flybys.
Carolyn Porco turns her attention towards Enceladus. And once Cassini arrives, a single photograph transforms the entire mission.
I was focused on Titan, but then my world changed. For me, it was really a oh my God moment.
In February 2005, the Cassini space probe makes a shocking discovery on Saturn's icy moon, Enceladus.
Our first observation turned out to have something coming off the South Pole. And it was clear. Everybody just went all abuzz with this, like, wow, there's something coming off the South Pole. Everybody was getting excited.
Scientists knew that the moons of Saturn were cold. And then they suddenly see these images of Enceladus, and they noticed a kind of activity that you don't expect from some sort of cold, dead moon.
The image shows a plume of material streaming miles above Enceladus. The Cassini team suspects that it's water, somehow ejected by a powerful amount of heat and energy. Carolyn Porco immediately contacts Chris McKay with the news.
Carolyn calls me up. I'm in a meeting, but I know if it's Carolyn, it's an important message. So I ducked out of the meeting, and I listened to the phone call, and I was stunned. And that's when I learned about all the interesting stuff coming back from Enceladus, evidence of energy coming from a subsurface ice environment. My world changed.
The reason why this discovery mattered so much is that it meant that there might be an enormous amount of really interesting chemistry going on there. The kind of chemistry that might be similar to what we saw in the early days of the Earth, maybe replicating the kinds of conditions that might give rise to life.
Our first thought was we gotta get a closer look, okay? And we gotta figure this thing out.
A few months later, the probe makes another flyby of Enceladus. And this time, there's no mistaking the power hiding underneath the icy surface of this moon.
And that's when we really had our, our socks blown off. because that's the picture where you see about a dozen narrow jets coming off the South Pole. We found out that heat was coming from these 4 fractures. But what is producing something so extreme?
Scientists believe the gravitational forces of Saturn are tugging on Enceladus, creating friction inside the moon. The evidence indicates Enceladus has massive amounts of water and a powerful source of energy. 2 key ingredients in the search for life.
And the next step is, can we say something from the molecules we see about the conditions of what's going on in the subsurface? Can we say anything about the presence of biology? Can we see anything that could be consistent with biology?
The team looks to find signs of organic material in the plumes. And what Cassini finds provides even more evidence that the building blocks of life may be brewing underneath the icy surface.
We have found that the particles in the plume close to the surface were salty, and they had a salinity comparable to the Earth's oceans. And that said that this body of water had to be under the ice shell and in contact with a core, in contact with a rocky core.
It could be an environment similar to hydrothermal vents at the bottom of Earth's oceans, a place where life exists.
So all of this put together said that we had a zone that could possibly sustain life. Okay, it had the basic ingredients. It doesn't mean it has the secondary and tertiary ingredients, but could it possibly be a place where, you know, if biological activity is not taking place now, it might be well on its way to taking place.
Over the next several years, Cassini continues to gather data and photos from Enceladus and its plumes. But in December 2015, after 10 years of flybys, Cassini approaches Enceladus for the last time. Carolyn and Chris are among the first people to see the final images.
This is the last flyby of Enceladus by Cassini.
These are the last close-ups.
That's right. Are you strapped in? Here we go. Look, oh my God. What? Well, those are just craters, but look at them. It's incredible, isn't it?
Really nice.
Oh, I wasn't expecting that.
We're going to be working with this now defined set for a long time.
Oh, a very long time. I mean, Cassini's been so incredibly rich. I bet we'll be working with Cassini data for 50 years.
But this final pass by Cassini doesn't study the plumes on Enceladus. If scientists are going to continue looking for signs of life, a new probe will have to go back. Because in September 2017, Cassini will end its mission and plunge into the atmosphere of Saturn.
For scientists who are looking for possibilities of life in the outer solar system, seeing these jets on Enceladus, this is winning the World Series and the Super Bowl all rolled into one. This is the best possible discovery they could make.
That's why Dr. Porco and her team are determined to return with a new spacecraft.
We're not sure that there's life there. We just have strong indications that there is at least an environment there that could support life, and maybe even an environment where life might have originated. So the thing that many of us want to do is we want to go back and, if at all possible, eventually bring back a sample to Earth.
To me, it eclipses everything else we know about the other worlds in the solar system. This is the single most important and interesting place for astrobiology in our solar system beyond the Earth. Can you tell I'm enthusiastic about it?
Coming up, there are many unexpected dangers to exploring the universe. But it turns out one of the most likely threats we've created ourselves.
Radar detected that something was moving very, very fast in the direction of the space station, and that a collision was a very real possibility.
Our exploration of the universe has opened the door to a world of new discoveries. Hubble has revealed that the universe is expanding faster than anyone realized. Cassini has opened new possibilities for life beyond Earth. But the most important discoveries could be in our own backyard.
The thing about the International Space Station is that it's in about a 200-mile above the Earth orbit, and so there's this wonderful detail. Pictures from the ISS to me often seem like abstract paintings. There are details of river deltas, or sand dunes, or forests, and they're works of art. They are so beautiful that I have to stop and look at these and just soak them in.
For 6 months, astronaut Ron Garan lived and worked on the International Space Station, and he saw our world in a way few people can imagine.
The Caribbean is like a glowing jewel. The Himalayas, the Middle East, there's many, many really interesting, beautiful places from space.
The space station gives us the ability to explore our home planet in a way we never could. But that God's eye view is getting dangerous.
We have a somewhat risky environment that we've created because we are surrounded, our planet is surrounded by this cloud of space debris.
3, 2, 1, 0.
For almost 60 years, we've launched rockets and spacecraft into Earth's orbit. But now, thousands of objects, from tiny screws and bolts to dead satellites, encircle the Earth, transforming the space above us into a junkyard.
It seems kind of comical, the idea that someday the Earth might actually be surrounded by some ring of space garbage, kind of like a less nice version of Saturn, but it's a real possibility.
Now, the International Space Station is in the crosshairs.
The International Space Station has already been hit by little bits of debris on a number of occasions, and there are no guarantees that other substantial things might not hit it again in the future.
It's the job of the military to monitor the thousands of pieces of debris orbiting the Earth. The men and women at Vandenberg Air Force Base in California are keeping their eyes on the skies 24 hours a day.
So currently we monitor and track approximately 23,000 objects in space. Among those is about 1,300 active payloads or satellites, and the rest being space debris from prior launches or prior collisions. Everyone on Earth should care about what's going on with space objects and space debris because we're so reliant nowadays upon technology that if something were to happen to a satellite, it's going to severely degrade our ability to do certain things, whether it be ATM withdrawals, GPS, or anything.
It's critical that we track space debris because it poses a risk to all the active payloads, including the International Space Station. Some of this debris we track up to 10 centimeters.
Even a piece of debris the size of a small screw could destroy the space station.
You can think of a 2-centimeter ball bearing up in space. It's traveling at 17,000 miles per hour. That force is equivalent to a Jeep Wrangler traveling at 70 miles per hour. So as the object size increases, the impact and force behind that collision could be astronomically larger.
In June 2011, Ron Garan found himself facing that danger firsthand.
I was maybe 4 months or so into the mission, and we got a call from Mission Control that a piece of space debris was going to pass a lot closer than people wanted. If we know about it soon enough, we will change the orbit of the space station. We can boost it up higher or lower and change it so that we avoid that object. But for whatever reason, this one caught us by surprise, and we did not have enough time for us to be able to move the orbit of the space station.
With the astronauts staring down the threat of a collision, they're faced with only one choice: abandon ship.
The International Space Station has several different ways of trying to deal with potential collisions, but the last-ditch defense are the 2 Soyuz space capsules, because those are basically lifeboats.
Ron and the crew race to the Soyuz capsules. Now, the only thing they can do is brace for impact.
And then it was just a waiting game after that. But we didn't know if it was going to hit it or not.
In June 2011, the crew of the International Space Station learns their lives are in imminent danger. Space debris is heading towards them.
NBC's Jeff Rawson watching all of this. Jeff, good morning to you.
Space junk was on a collision course with the International Space Station. Spotted so late, there was no time to move out of the way. Instead, the 6 astronauts got the order from Mission Control.
The probabilities are still in the red threshold, and we are planning to have you shelter in place.
If all else fails, the astronauts on board the space station can climb into those Soyuz space capsules and wait to see whether a collision actually takes place. If it does, they can in a few seconds detach from whatever's left of the space station and then immediately try to return to Earth.
Mission Control orders the astronauts to the Soyuz lifeboats. It's only the second time a crew has been told to potentially abandon ship.
Once we got all the hatches closed and when we were all buttoned up in our Soyuz spacecraft, there really was nothing to do but wait. We discussed, okay, if things get really bad, this is what we're going to do. We're going to undock. We're going, we started to talk about that, and then it was just a waiting game after that. But we didn't know if it was going to hit it or not.
Finally, after 15 minutes, word arrives from Mission Control.
When the object passed the space station, we got a call from Mission Control that it was all clear. And it turned out that this object passed within a football field of the space station, and relative velocity was 8 miles per second. So it's a fairly large object traveling that fast. It probably would have destroyed the space station had it hit it.
But with thousands of objects orbiting the planet, the next time, they might not be so lucky.
There is evidence of hits on the space station and, a little piece the size of, a grain of sand that, really make a bad day. It's something that should be a major concern if we're going to continue to use the environment of space for the things that we want to use it for.
Exploring Earth in the 21st century means capturing it from above. But space debris is not the only threat to this unique perspective.
The sun seems to be always there and unchanging. It's just this bright ball of light in the sky. But in fact, it's changing all the time. And that affects us here on Earth because we are bombarded by radiation from the sun, both in the form of light and subatomic particles.
The Earth's atmosphere is a protective shield for anyone on the ground. But in space, there's no escape from the power of the sun.
Solar flares and other kinds of violent eruptions from the sun are very, very dangerous for anybody who's in space. The amount of radiation that suddenly is pouring off of the sun at that point jumps way up. And we can try to create certain kinds of very shielded areas that the astronauts can hide in, but even those can only offer a very inadequate protection against the level of radiation that the sun can suddenly release at those times.
An extremely powerful solar storm could send the crew looking for cover.
What we would do is we'd find a place on the space station that offers the most protection. Water turns out to be a fairly good insulator of radiation. We do have bags of water on the space station, and we'd probably huddle some bags of water into a location and get behind that as best we could.
But in spite of that danger, the same powerful burst of energy also gives the astronauts on the space station front row seats to the greatest light show imaginable.
The auroras are just incredible. And there were times on my mission where we flew so close to the auroras that you could reach out and touch them. I mean, they were going right by the windows. It was absolutely incredible. The pictures really don't do them justice. They really do dance.
But what you're seeing, really, is the after effect of a tremendously energetic and dangerous solar storm. These subatomic particles screaming across the solar system and just under the speed of light are getting swept up by the Earth's magnetic field and funneled down into our atmosphere. It's humbling and amazing.
From discoveries at the edge of the solar system and beyond, to mysterious asteroids hurtling through the cosmos, and the search for life in our own backyard, images have transformed our understanding of the universe.
Everyone knows the cliche, a picture is worth 1,000 words. But to me, being a scientist, you have to find a way to turn cold numbers, just data, into something that emotionally resonates with people.
We are trained to be very, very logical. But all of us really are just like everybody else, and we're emotional, and, we get excited about a beautiful scene and can, just spend hours looking at something and imagining what it would be like if we were there.
And these images are the result of cutting-edge missions, driven by the explorers willing to put everything on the line to capture space's deepest secrets.
These days, I think we've seen that there's a whole new team of heroes. These teams of scientists and engineers, they're the ones inventing these craft. They're the ones devising these missions. They're the ones making sure they come off without a hitch. They're the real heroes now.